We are back with Eric Bachman of CO2Rail, which this is part 2 of our interview. Part 1 can be found in the latter half of episode 780, which is available at our website at greenmajority.ca. And we're going to dive in a second to the bigger questions, but to orient folks who may have missed the first episode, my understanding, and I'll throw to you, Eric, in half a second, but correct me if I'm wrong, is that CO2Rail is a direct air capture technology that aims to harness the incredible amounts of energy that is wasted by breaking trains. Thank you so much for joining us back on the show. And can you give us a bit of an intro?
Yeah, first, thanks for having me back on. I appreciate it. Really enjoyed our last conversation and look forward to another one. CO2Rail is a rail-based multi-gigaton scale direct air carbon capture system that, like you said, utilizes the tremendous regenerative braking energy generated from stopping or slowing an entire train many times per day. It also has no land-based footprint and no need for energy-hungry fans to move air through the system as it collects its air from the train slipstream. The bow on top of all of that is it can even remove the emissions from the locomotives themselves, which would create the world's first carbon negative mode of transportation. You don't hear that very often, do you?
I mean, I've never heard it. So yes. And so that's what we're talking about. And I teased at the very end of our last conversation that this one would include a description of what this looks like, because I feel most people probably don't even actually have a really good understanding of what regular direct air capture might look like, let alone what it looks like to strap it onto a train, and let alone to have that also, have solar panels on top of it to get powered. So can you paint a picture? What does this look like?
Sure. Yeah, I was meaning to get to that last time. The features that we needed for a great rail car are almost exactly what exists currently in railroad tank cars. A large chamber that's airtight, able to store liquid CO2 at high pressures, but also has the potential for good aerodynamic flow characteristics. So now imagine that tank car with large air intakes mounted on the top side of the tank. The front part of the rail car is where the main equipment is located, such as the compressor and control system. Underneath the car, there are boxes mounted for the battery array, and a portion of the rear of the car is used as a reservoir to store the harvested CO2 until it can be offloaded. The entire rest of the car is the CO2 collection chamber. This is used to house the deabsorbent and designed to take the intake air down through the media and out again, minus its carbon dioxide.
So it's basically, if I can try to see if how well I understand this, it is like a big tube on top of a big tank covered in solar panels.
Exactly. And the primary way it's powered is the regenerative braking energy from the train, but it also does have solar panels mounted on top, mainly to keep the battery charged during any period of downtime.
That makes sense. And then the direct air capture happens because there's filters inside the tube that the air flows through as it's going through.
Absolutely. Exactly right.
Amazing. Great. Okay. So now I've got a sense of this. And so I have a 2-part question. The first is, how much could a single one of these cars, right, how much could it hold before it got full? And then the secondary question is, what does the scale potential look like?
That's a great question. The first question that everybody asks, and we're going to need some ramp up time to iron the kinks out, but we believe on a per car basis that we can get to 20 to 30 tons per day. And at scale, meaning that we have these cars deployed around the world, we believe we can get to definitely 1 gigaton by 2030 and 5 gigatons by 2050 and 10 plus by 2075.
Cool. So I have a question that may not be, I'm going to say fair, but this might be too difficult to actually do in your head right now. So it's just more of a curiosity question for myself, which is,
go for it.
It's hard right now to understand these scales. Like a gigaton is a number that I totally have very
Right.
little
Okay.
handling on. And
Sure.
so I know that the largest direct air capture just opened up like a couple weeks ago. And so in the future version of these cars, how much of the cars would match one of these, what's opened up 3 weeks ago?
Yeah, great question. So I think you're talking about the Climeworks plant that just opened in Iceland. And off the top of my head, I think they were at 4 or 5 thousand tons per year capacity at that plant. First of all, let me say that I absolutely support what Climeworks is doing. I think it's a great company and they're doing some really exciting things. And like I said last time, this is bigger than any one company or even any one country. So again, I'm a big Climeworks fan, and they're going to be opening plants up elsewhere that are, I know, bigger and better than what they just did in Iceland. But at that capacity, one of our cars at scale would be able to do about twice that per year.
Cool. And the goal here is to have multiple cars on the train, on each train.
Right. So there's enough energy on most trains to have multiple cars, especially the trains that run out west. They in the mountains areas. Uh, a lot of people don't know this, but as they're not only do you have to go up the mountain, but you also have to come back down the mountain. And coming back down the mountain, they use a lot of energy braking for an extended period of time to decelerate the train rather than having to ride the brakes. So, especially out in the mountainous areas, we believe in the near term we could have as many as 5 or 6 of these cars per train.
I hadn't even thought about the fact that this would be even more effective when you're going downhill because of how much you'd
Yeah.
have to stop it from going downhill so quickly. So you mentioned scale, and I think that is ultimately perhaps one of the big concerns around direct air capture is, as we talked last week on the show, I think we covered one of the big concerns, which was just that it's a distraction from what we have to do because of just how quickly we must decarbonize everything else. And we had a conversation about how we need everything right now. But the second concern is just that even if you accept the possibility is there, the speed at which is necessary, the fact that the largest direct air capture just launched, and it's the equivalent of taking 790 cars off the road for a year. And so the scale that we need to see in this sector overall is huge for it to have a real impact on climate change. And so I'm curious if you see a path forward where that is possible, like where this is able to scale up fast enough to really make an impact.
I think so. There's some really, really exciting things happening in many areas of direct air capture. I think some of the most exciting progress has been made in the sorbent media. That's the filter that will capture the CO2. For instance, MIT is developing what's known as electro swing direct air capture media. And I won't get in the technicals about it, but it offers not only substantial savings on the energy side, but also substantial time savings on the desorption side. That's where the carbon dioxide is released from the filter and then captured. So we're at the point in direct air capture. I think the common terminology would be an inflection point where there's been many years of kind of run-of-the-mill progress and then increased progress and increased progress. I think right now we're approaching a more exponential level of progress or an inflection point where, let's talk about Climeworks. You're going to see their 4,000 ton turn into 40,000 ton and then turn in hopefully into 400,000 ton. And the same with us. We just began operations last year and we have made light years of progress already, which is very exciting, but also challenges. And we can get into some of those challenges if you want. But to finish out answering your question, yes, I do believe direct air capture can scale. I believe it has to scale. And rail has been growing about 1.5% a year for a long time. Obviously, that's averaged out, but over the last, I think, 15 years, it's grown at about 1.5%. If that continues, you get into in 25 years, 5 gigatons a year. That's a lot of CO2 removed from the atmosphere.
For sure. So obviously, this type of technological rollout is not something that most people ever have to think about or experience, really. And so, and again, no worries if this question is too hard to answer, but I'm wondering if you could just walk us through like this next steps. So like you started last year, you're now, is it a year or two to a prototype and then 4 to something? Like I'm just curious what this looks like.
Well, the quick answer is a lot of imagination and a lot of banging your head against the wall. You mentioned batteries. That's a huge issue. We need batteries for our system, and it's both good and bad. There would not be a lithium battery shortage if there wasn't a tremendous demand for renewable sources of energy and green transportation. So it's good and bad. It's bad when you're trying to develop a new technology that depends on batteries, but that is just a shortage like that is a spawning ground for new technologies. You have good days and bad days. The good days are when you find a solution to a problem. The bad days are when you uncover a new problem, and they seem to come at a 1-to-1 ratio, which I guess it could be worse. It could be a 1-to-2 ratio, but yeah, you just walk through it step by step, I guess.
I mean, yeah, fair. So we got connected to you because in another interview with Alex Tavasoli, I asked what was something that she was experiencing that she had heard about in her sector that she was really excited about. And her answer was CO2Rail. I'm curious, like from your perspective, what is the thing that you're experiencing that you're seeing out there in the world that you are excited about, that you think is like, oh man, this thing is really neat if it works, or oh, I hadn't thought about trying to solve this problem this way, from your own bubble.
Well, that's a great question. I have to, obviously, because I'm in this industry, I have to say that I'm, most excited about what's being done in direct air capture, like what Climeworks is doing in Iceland, and even in Canada, what carbon engineering is doing in Alberta. Very exciting. I think the potential for syngas or synthetic fuels is very exciting, and the progress even at University of Toronto, the solar fuels group, they're run by Professor Ozen. Very exciting. Using solar energy to synthesize fuels. That kind of blows my mind that that's even possible, but they're doing it. I think this is what everybody's excited about, is the broader deployment of renewable sources of energy, solar and wind. Very exciting. But again, what I'm most excited about, what I think is a real bottleneck in all of this, from transportation to energy to direct air capture, at least our part of direct air capture, is advancements being made in battery technology. Renewables, as everybody knows, are not as reliable as carbon heavy sources of energy. With solar, you obviously have night. With wind, sometimes the wind doesn't blow. So we're going to need energy storage to reach the broad deployment that's necessary for decarbonization, and very little ways to get there without tremendous advancements in battery technology, and hopefully battery technology that gives us some choices beyond lithium and cobalt. There's obviously some environmental concerns with both of those elements, unfortunately. So hopefully that answered your question.
It certainly did. So Obviously, with any sort of new technology, you will be facing a series of different challenges trying to get rolled out. And you've mentioned a few of them already. And what if you can dive in a little deeper to what do you see as the biggest challenges that you face, and how do you imagine getting past them, I
Right.
guess?
Yeah, it's a great question. It's exactly what I spend a good portion of my day trying to solve. And there's a lot of them. I mean, obviously, the quick answer is like any startup, like any new technology, even a disruptive technology, like I believe ours is access to capital. It's always the first answer, I'd imagine. Along that line, I would like to have a prototype out there testing. It's definitely in process this time next year, and hopefully on the railroad testing first part of 2023. Beyond that, everything gets worked out in testing and prove out. We're going to have to scale tremendously to achieve our projections. Approximately 500,000 of these rail cars will have to be manufactured over the next 20-25 years at a rate of about 25,000 per year. It sounds like a lot, but it's absolutely feasible. If you look at the rail car manufacturing sector, just in North America, they turn out something like 50,000 rail cars per year. So yes, they'll have to scale up, but it's not a unreasonable scaling that would be required. And trust me, they'd be happy to scale up by that amount. And plus, those are all good, high-paying jobs that will really benefit the overall economy on a permanent basis, because these cars will have to be built. Now, if you look at their lifetime of say 20-25 years, that a portion of the fleet would have to be replaced after that time. I haven't really talked about this much, but part of our concept involves application of solar cells on some of the compatible rail cars in a train. That would need to start and scale up year over year. Third, the efficiency of DAC media would have to increase, meaning the energy required to capture and then release in that filter media would have to decrease. But there's a lot of great advancements. I mentioned MIT, a lot of great advancements being made, and we're pretty confident that's going to happen. Fourth, and perhaps most important, and we touched on this a little bit, rail traffic will have to increase year over year from where it's at now to approximately 40,000 trains by 2050 and 50,000 trains by 2075 to achieve our CO2 drawdown targets. But even that's feasible. Again, rail has been growing, which is a good thing. And given that rail uses approximately 90% less energy than trucks per unit of delivered freight, and with our system, it would be the world's only conceivable carbon negative mode of transportation. Every time I say that, I get all giggly inside. But yeah, it could be powerful incentives for shippers to use rail. In fact, if just 30% of truck transport was diverted to rail, there'd be a 10,000 train per day increase almost immediately. Say, fifth, along those same lines, not only do we need the number of trains to increase, but those trains will have to become heavier and faster. And you ask, what does that have to do with anything? A heavier, faster train has more kinetic energy. And since we are, in essence, harvesting the kinetic energy from a train through regenerative braking, a heavier, faster train will lead to more energy available to remove carbon dioxide from the atmosphere. All those I mentioned, and there's more, but all those I mentioned are enormous challenges, but they're equal or greater challenges with all types of DAX deployments. Nobody said it's going to be easy. It's just likely to be necessary. And actually, three of those challenges are shared challenges across all types of DAX deployments, massively scaling up unit production capabilities, developing renewable sources of input energy, increasing DAX efficiency. There'll be universal topics of discussion, no matter if your rail DAX solution has wheels like ours or remains terra firmly affixed.
So when we were talking off air, you had mentioned the set of auxiliary benefits that exist outside of this. Obviously, the main thing here is removing carbon from the atmosphere, but there's a bunch of other stuff that this also does. So perhaps you can spend a bit of time just letting us know the other just fun benefits that exist to using a train-based way to suck carbon out of the air.
Yeah, great question. This is one of the very few projects I've worked on in my career where, usually when you solve one problem, another problem pops up, and hopefully the problem you solved is bigger than the problem that you unsolved. But this has, I hate to use the old tired phrase of synergy, but this has a lot of synergies that are pretty exciting. So besides the energy and the cost advantages, these auxiliary benefits are really exciting. Of the challenges I just talked about, 4 of those are related to rail, but solving for them benefits far more than just rail or even carbon capture. To begin with, rail is, like I said, a very efficient mode of both passenger and freight transport, and increased rail traffic means less truck traffic, less traffic congestion, higher workforce productivity. It would take you less time to get to the office, so you'll be more productive. And likewise, you have a higher quality of life, fewer, highway accidents, and far fewer corresponding emissions, not only truck, but also on the auto side, because rather than millions of people sitting in impenetrable traffic every day, idling their engines, you can count on a quicker commute and far less emissions. So again, by solving for how do we get there, how do we get to 10 plus gigatons, which is where we need to be, reduce, increase rail traffic and reduce automobile traffic. Another example would be increasing the regenerative braking output on trains will mean more use of automated train braking systems, and that will lead to safer trains, fewer accidents and derailments. And we spoke about faster and heavier trains, but that also means more energy to remove carbon, but also will require increased investment in rail infrastructure and more efficient transportation networks, and hopefully increased rail utilization on both the passenger side and the freight side. And all that will still lead to less emissions. So everything that we need to scale up, I think benefits the public and also benefits the environment, because what we need to scale up to reduce carbon dioxide requires a reduction in carbon dioxide by increased utilization of rail. It's pretty exciting.
Awesome. And so second last question. The last question is going to be the very easy one, which is just how folks can stay up to date your work. But this question, a little more involved, but does have a bit of a time-based element to it, which is, say you've convinced someone now and they want to convince somebody else that this is a good idea or that there are serious benefits here, and they've only got 2 minutes. How do they do it?
Wow. 2 minutes. Well, let me read something that was recently written by somebody there at University of Toronto. I mentioned before, Professor Jeffrey Ozen. He's somebody I consider to be one of the all-time heroes in sustainable development, decarbonization, carbon capture. And he's been a real champion of ours and very much appreciated, and an indispensable resource as well. He wrote this about our system. And I quote, "The investment will be enormous with any DAX solution, but if in developing one, we can not only remove carbon dioxide from the air at the gigaton scale, but also take advantage of a currently untapped source of clean energy, save upwards of 30 billion per gigaton in direct costs, forego permanent adulterations to our landscapes, and allocating a quarter of our global energy capacity to DACs, improve critical national infrastructure, transportation safety, rail utilization, speed, and efficiency, reduce traffic congestion, accidents, and highway fatalities, increase workforce productivity and overall quality of life, create legions of skilled, high-paying jobs on a permanent basis over the next decades, build legislative, popular, and corporate support of climate change mitigation and carbon removal programs, and finally, drastically reduce rail, truck, air, and even auto-related emissions in a myriad of meaningful ways. The choice becomes quite simply when, not if. CO2Rail just might help get the current bleak picture of climate change back on track into a future, brighter one of climate change back. Wow. I couldn't add anything to that if I tried. And
I mean, he's got such a good pun there. Back on track. How could you go
I know,
wrong?
right?
It's
Climate change back. We actually made that our corporate motto after I saw that.
Awesome. So if folks want to stay involved, as you mentioned, this is a fast growing, and I'm sure it'll be a consistently changing environment, especially if you're hoping to get a prototype out next year. How can folks stay involved or stay connected to your work?
Sure. Yeah. Much more information is available on our website. That's www.CO2Rail.com. We're also on Twitter at CO2Rail. And our email, if anybody would like to send us a message or has an idea or anything, is admin@CO2Rail.com. Another thing is just launched a portal on our website where you can offset your carbon footprint and support our efforts, and a pretty neat feature if anybody would like to help us out. Again, that's CO2Rail.com, and just click on I think it's the carbon footprint tab, something like that. But anyway, thanks for having me on again, and it's been a real pleasure.
Yeah, thank you so much for being here. As always, this has been part 2 of our interview with Eric Bachman of CO2Rail, the Principal and Chief Technical Officer. Thank you so much for being here. And again, if anyone has any questions for Eric and they want to shoot them to us, we'll happily relay them that way as well, if that's easier for y'all. Thank you so much, Eric, and have a wonderful day.
Thank you very much.